Professor Bob Young back again, and we're going to continue our discussion of complex numbers, looking at some operations of complex numbers. And the Frenchman René Descartes, when he came up with this concept, started saying, oui, I can make my complex numbers behave like polynomials in algebra. So what he did is when you can add and subtract complex numbers, so we're going to look at how he did this. And all he did was, it's just like adding polynomials in this example, he added the real parts together. So we'll go ahead in green and underline these, 3 and plus -2. And if you look down here on the bottom, we just got 1. I mean, it's just showing you the breakup here in this graphic here. And then we'll take a different color here, and we'll underline the i's. Minus 4i plus 6i gives us plus 2i. So it's really just adding the real parts together and the imaginary parts together whenever you add complex numbers. And here's another example. So again, we're just taking, and we'll go back to green here, and we'll underline the -9 plus 3 gives us -6. I know some of you are saying, put a lot of these on the test, Young, put a lot of these on the test. There will be at least one of these, so that's good. 7i minus 15i gives you -8i, and it's that easy. So always be sure to put the real part first and the imaginary part second in the standard form we've been talking about. Now in the next example, be very careful, because what happens here, what a lot of students fail to do when you subtract complex numbers, is they forget to distribute that negative through there, rewriting this as -4 plus 3i, and then when you subtract, oh, those signs are killers, you get -6 plus 7i. And boy, this is one of the most missed signs in algebra right there, is when you fail to distribute that -3 there. And then we can still continue with that thought, so we'll just take the -4 and the -6, and there is your real part to get -10. And then in purple again, we'll take the i's and underline them, and they're showing this minus and negative in here as well. Be careful, and you get the -10 plus 10i answer. And just one more example here is going ahead here. Now I've noticed they're not showing their steps. Oh my gosh, I wouldn't want y'all to do this on your homework, or if you're submitting work for a test. I always like to see the work, so you know, in case you copy something wrong or whatever, I can check it. So again, we're going to take and distribute that negative sign through there, being very careful, and then we can combine the real parts and the complex parts to get, and here's where I like to use colors. I don't know if everyone likes colors out there, but you can then see the 12 minus 8 gives you a +4, and then -5i plus 3i, -2i, again in standard form. Now, I know what some of you are thinking, Young, what if I put -2i plus 4? Isn't that the same thing? Yes, but it would make Descartes roll over in his grave. Because those of you that go on and take any electronics courses or things like that with electricity, engineering, so forth, you will see a lot of these, and you must be able to write it in the correct notation. Continuing, let's go ahead and talk about multiplying complex numbers. And here, the most dangerous part of foiling complex numbers is the L on FOIL. Okay, now it's showing you the big breakup here. Now this could be a little bit confusing. All this really is, whenever you FOIL two complex numbers, is that would be the first outside, inside, last. Now again, why is the L so dangerous? Because that one always produces I squared, which remember is a wolf in sheep's clothing. It is the number -1 in disguise. So always be careful when you FOIL those, and it's got this big breakdown here. I don't know if all this is necessary. So, and again, they're showing another breakdown here of A, B, C's, and D's and stuff. Now, that really doesn't make a lot of sense to students, so let's just go ahead and get to an example here. And we'll put some numbers in for A, B, C, and D, and I think it'll make a lot more sense here. So let's multiply the two complex numbers 2 minus 3i times 3 plus 4i. And what I like to do whenever I FOIL is to write out the FOIL. So 2 times 3 is 6. The outside two terms would be plus 8i. The inside two terms would be minus 9i. And then the last two terms, and there's the dangerous part here, the L gives you a minus 12i squared. So be very careful here, because this indeed is minus 12 times a minus 1, which really comes down here and gives you a plus 12. So we're going to add something to this graphic here. So this would be 6 plus, and I'm just going to go from this step here, 8i minus 9i plus 12. And then I think it's safe to go ahead and go to this step. I don't know about that step in between here. So let's go ahead and add, and we'll go ahead and go with our green on the real part again. 6 and 12 would give us the 18. And then the 8i minus 9i would give us minus 1i or minus I. So be careful whenever you multiply the complex numbers. That L is dangerous. Now here is a complex number squared. Now really, this again is a FOIL problem in disguise. So really, if you have 4 plus 3i squared, it just means, well, that's 4 plus 3i, not once, but twice. And then we can go ahead and do the FOIL here. Now what happens when you FOIL this, and I think I'll just write this out before we go on. A lot of students may not see right away what happens when you square a binomial. Some know that little rule for squaring binomials, but I just go ahead and write it out. So first two terms, 4 times 4 is 16. 3i times 4 is plus 12i. Now when you square a binomial, the O and the I will always be the same. So you'll get 12i inside as well, and then plus your dangerous last term of 9i squared. Okay, so again, be careful here, because this is going to be 9 times negative 1, which if you look down here, it's going to give you a negative 9. So we're going to end up with 16 plus 24i minus 9, and that'll give us the final answer. Okay, so when you multiply complex numbers, just be careful here. Now this is one we're really going to get into later on here when we divide. This is called conjugates here. Whenever you have the same binomial except the sign in the middle is different. Now whenever you FOIL conjugates, so I'm going to write this name here because this is going to be important in future lessons. Conjugate. That's a U there, sorry. Conjugate pairs is what they're called. I've got a little tricky saying I like to use on these. Whenever you FOIL conjugates, FOIL goes to Florida. Because what always happens is the O and the I go out because of the signs. See, so if you remember that, whenever you FOIL conjugates, FOIL goes to Florida. You're just multiplying the 6 twice and the 5i twice with the minus in between there. And what happens is you get a real number because the i's will go out. You'll have 0 i's in the answer, so you'll get 61 or 61 plus 0i. And this always happens whenever you multiply complex number conjugates. So something to keep in mind as we progress. So that is lessons on adding, subtracting, and multiplying complex numbers. Professor Young signing off.